In this video, you will learn about translations and glide reflections. So to begin, let's discuss translations. What are they and how can we describe them? So translations would be the sliding or moving of an object. So with this, just the location of an object is changing, and because of that, this would be considered an isometry because the distance of the sides of the shape is staying the same. And another name we give to this would be called a glide. So a sliding or a moving is also called a glide. And a way to remember this, by the way, kind of a dumb way to remember, but it might be helpful, is translations, SL, in translations. That is the sliding, SL, in the word sliding. All right, so that may be helpful for some of you to remember that a translation is the sliding or moving or gliding of an object. So an example of this would be right here, this L shape. This would be called your pre-image, and then we can translate or move it across like this to get to our image. So we just simply move it from point A to point B. Now the translation doesn't have to be across like that. If this is our pre-image right here, this green kind of cross shape, we could translate it across like this. We can move it kind of diagonally, and this would be now our image. So it doesn't matter which direction we translate or move the image, as long as all we're doing is just moving and not reflecting or any other thing. So here's an example. We have this picture, and you have this triangle with different points, and what we're doing is we want to translate this entire triangle. So what we do is we have to move each point the same distance over to some other location. So here we have these red lines to show you where these points are going to be moving to. So it's going to move in this direction, that distance, over now to get this new triangle right here. All right, and there's a relationship between each of these points. So this point A is being mapped down here to A prime, which is going to be 0, -2. Look at the x value of both A and A prime. Here it's -4, over here it's 0. So we had to add 4 to get to that x value. So we took x and added 4. All right, and we see that is going to be the case for any of these points. So if you look at where it starts and where it ends, so like point B and point C, okay, notice point B, the x value is 6, and it goes down here, you add 4 to that to get to 10. Same thing for C. We start at -7 for the x value, and we had to add 4 to get to -3. And same thing for the y component. So look at A to A prime. It went from 7 to -2. So what we did was we subtracted 9 to get to that. And same thing happens for each point. So B goes from 3, and we subtract 9 to get to -6 for the y value. And then the C point right here, we subtract 9 from 1 to get -8, which takes you to this point down here. So we can write this translation in the following manner. So here in the mapping notation, we can call this T colon, so T stands for translation. And what we're doing is we're mapping the point xy over here, where now x you have to add 4, and the y we have to subtract 9. So this would be a way to describe this translation, is with this mapping notation. And this will be true for any translation where we start with an x and a y value, we start with some ordered pair, and we can add or subtract some constant. And this gives us a formal definition of a translation. So you can define a translation as a translation T, which maps any point xy to the point x plus a and y plus b, where a and b are just some constants or just some numbers. So let's get some practice with this concept, with the notation. So here we have a few examples, and we're told that we have translation xy that maps the point xy to x minus 4 and y plus 5. And given that information, we're trying to determine where would the point negative 3, 7 be mapped to? So to do this, we just look at this, this function right here. So we take x minus 4 to get the x value. So we take negative 3, put that in for x. So negative 3 minus 4 would give you negative 7. And then notice that we do y plus 5 for the y value. So we take the 7 and add 5 to get 12. So this point of negative 3, 7 would be mapped to negative 7, 12. Now try this next one on your own, see how you do. Where would point 4, negative 6 be mapped to? So what you do, again, is you would take the 4 and plug it in for x. So you have 4 minus 4, which would give you 0. And then for y, we do y plus 5. So we do negative 6 plus 5, which gives you negative 1. So this point 4, negative 6 would be mapped to the point 0, negative 1. Now here's another example where now we have translation where you have the point 7, negative 1 being mapped to 2, negative 4. And given this information, what we're trying to do is we're trying to determine where would the point negative 3, 7 be mapped to. So to determine that, we have to figure out what's happening with your pre-image and image. Look at the x values. To get from 7 to 2, we had to subtract 5, right? Same thing with the x value here. Subtract 5 from negative 3 to get negative 8. That gives you the x component right here. And then look at the y component. Here we have negative 1, and we had to subtract 3 to get to negative 4. Same thing for the 7. We have to subtract 3, and that would give you a positive 4 right here. Let's try another example with the same given information. We're trying to figure out where does the point 4, negative 6 map to. All right, so for this one, again, same thing. X value, we had to subtract 5 up here to get from 7 to 2. So for 4, we subtract 5 as well to get negative 1. And we said for the y value, from negative 1 to negative 4, we had to subtract 3. Same thing with negative 6. For this y value, we subtract 3 as well to get negative 9. So this point would be at negative 1, comma, negative 9. Now one more thing we need to finish off with, and that is what we call a glide reflection. Now a glide reflection is basically a combination of transformations. We see the word glide. Remember that was another term we gave to a translation. So what we have is a translation with a reflection. So it's both put together into one motion. All right, so that's our definition. It's a translation, or sorry, transformation. So that should be transformation. Transformation that combines a translation, or a glide, and a reflection. So what would this look like? Well, here we have triangle ABC, and we have this line of reflection right here. So it's combining a glide and reflection. So we can take this figure, and we can glide it across, or translate it, move it across over here to get this triangle A prime, B prime, C prime. So we have done the glide, or the translation. Now we need to do the reflection. So we can reflect each of these points, so the A prime, B prime, and C prime, as we've learned in the previous lesson. We can reflect each of these points down across to get this triangle down here. All right, so this would be a glide reflection. We translated or moved it across like this, then reflected across this line of reflection. So take note that with a glide reflection, it does not matter the order in which we do the glide and reflection. So we could glide first and then reflect, or we could reflect and then glide. So the order makes no difference. But make sure that when you do the glide, that the glide is parallel with the line of reflection. So this glide must be across like this in this particular case. We can't just take it up here in this direction, because that would not be parallel to the line of reflection. And that concludes our lesson for today. We will see you next time.